This is for the second problem of Project 5. In this project, we are discussing cryptanalysis, and as a tool, we are asked in this problem to create count.rb. Well, in fact, we have its template in a directory project proj5. Let us check it. So activate terminal and then go to the proj room. cd cs proj5. Then ls to check the files there. You see, we have the program count.rb, this program. Okay, let's see this program with the editor. Start code editor, file, open, and then count.rb, open it. Okay, this is the current program. We need to complete this by writing this part. As we discussed in the previous session, after reading the ciphertext and preparing the array FREQ, FREQ, the actual frequency counting will be done in this for loop by reading characters of the ciphertext from its beginning to the end. More specifically, in the body of this for loop, the ith iteration, the ith character is examined, and the value of the array FREQ should be updated appropriately. But in this current program, we only have this statement print. Okay, that simply outputs the information of the ith character. That is, character itself, its code number, and its distance from letter A. That is computed here in the variable dist. Okay, we need to modify this part. But before our modification, why don't we first execute this program? At the terminal, type ruby count.rb. Here, the program waits for an input string. So let's type in, for example, A, B, C, X, Y, Z, capital A, Z. Okay. You see, the information of each character of this input string is shown line by line. For example, the first line is about the leftmost character, A. Okay, that is A, and its code is 97, and then the second, and then distance from the letter A is 0, trivially 0. The second line is for the next character, B, and so on. Note that last two characters are capital letters, so their codes are less than the code of the lowercase letter a, and they have negative distance, -32, -7, respectively. In the last line here, the program outputs the array FREQ. By the way, by using this print command, okay, we can show the value of all boxes of the array nicely in this way. Okay. Here, it shows that the values of the boxes of the array FREQ are all 0. Well, this is clear because we didn't update these values in the current program after setting the initial value 0. Now, let us consider how to update the array FREQ. First, recall that we are interested in only lowercase English letters. So as before, we check whether the current ith character is a lowercase English letter. We can do this check by considering its distance like this. So if 0 which is no equal dist and dist 25. Okay, let us also at the end this ending statement. So we need something to do. here for counting, only when this if condition holds. Otherwise, we don't need to do anything. Suppose that the ith character is a lowercase English letter. Note that the type of character, this character, is uniquely determined by the value of dist. Okay? For example, if dist is 0, then the character should be A, letter A. If dist is 1, then the character should be letter B, and so on. Furthermore, we are planning to store the frequency of each character in the box fleck dist. At this point, suppose that the number of occurrences so far of this character is indeed stored in the box fleck of dist. Then what we need is to increment this number by 1 for counting the current occurrence of this letter. So what we need to write here, okay, is a statement like this. Okay. Update fleck dist in this way. +1. Okay, let me read out this statement. First, compute this expression, fleck dist +1. Okay, this is the current value of fleck dist incremented by 1. Then this value is stored in this box, the same box, fleck dist. Okay, and then so the value of fleck of dist is updated by this incremented value. Let's execute this modified program. By the way, in order to check the computation, let us also add the print command here. Print command here to show the array fleck each time. Print. And then also comment out this statement that is no longer necessary. Okay, so let us save it and then execute the count.rb. Okay, let's type in, for example, AB, AB, ABC. Okay, here is the result. You see, the first character, A, okay, is the lowercase letter A. Okay, so the value of fleck 0, this box, is incremented. Then, since the second one is B, and the value of the second box, fleck 1, is incremented. Okay. On the other hand, the third and fourth characters are not lowercase. So the array fleck doesn't change. Okay, here and here doesn't change. Okay. Then, by processing AB here, again, the value of the fleck are appropriately updated here and here. And then the last character C is a lowercase character, and then third one is updated. Okay. So, and then this is the final result. So letter A appears twice, letter B appears twice, letter C appears once, and then there while the other letters have not appeared. Let us try some more examples. But before doing this, let us comment out this print command. Okay. So execute this program. Okay. Then type AAA, B, C, D, X, Y, Z, X, Y, Z, 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 Z. Okay, for example. So here is the result. You see how array fleck is updated. Then the final values is like this. Okay, this is what we wanted. A appears 3 times, B, C, D and then X, Y all appears once, okay? And then Z appears 4 times. Okay? Finally, let us examine the file extxt. Okay? Here we have a file ex.txt. This is the challenge ciphertext that we want to decipher by cryptanalysis. First, let's see this file cat ex.txt. You see, this is our challenge ciphertext. Well, we cannot understand what it says. Now, let's examine the frequency of each letter in this ciphertext. Okay. Count. Okay, and then ex.txt. Okay. This is the result. This shows, for example, letter A appears 63 times in this ciphertext, and Z appears once. Seems like this letter, this one appears the most, 154 times. In the next session, we will discuss how to identify the most frequent letter and how to use it to guess the secret shift number.